presented by Coding Club NIT Silchar. Here we will discuss a few problems which are uh, selected by us and will clear some of the concepts. So I will start with the problem make it permutation. So in this problem we have given an integer array of length n and there are two kinds of operation which we can do. First operation is to remove an integer from the array A and this will cost us C amount of cost. Then the second operation is to add any element in any place of the vector. So to the front, to the back, or between any two consecutive elements. This will cost us d. Uh, cost us d. So we were you want to make the final array any permutation of any positive length. So our aim is to make the permutation. So final array must contain at least one integer. So as we all know, a permutation is just uh, a number which will be there in the array of the same size. For example, here 23154 is a permutation because all the numbers from 1 to 5 are there and the length is 5. So this much is the problem statement. The input consists of the first is t, which is the number of test cases. Then we will be taking three integer ncd. N is the length of the array. C is the cost of removing the integer, and D is the cost of adding one integer in the array. So for this, we are going to discuss greedy and DP solution of this problem. So first, I will start with the greedy solution. Here, first we will take the inputs NCD. Okay, I have taken the inputs NCD. Then I will take the input in the array which I have defined here of this size. Okay. After that, I will sort it so that I can get the elements in their consecutive position where it should be. For example, if 4231 is given, then after sorting, one will come to the first position so that I will be easily identify where which element is present or not. After this, I will take two variables count and repeat. Count will uh, and I will use it after I am going to execute the loop. So first of all, I am going to declare a variable answer. Here, this will be the worst case of the value, which will be removing all the elements and adding one to the permutation to make a permutation of length only one. So if this is the maximum worst value which we can get here. For that, I will remove all the elements n times c and then add one, which will cost me d. After that, I will go through the loop here. If because we have sorted, all the elements will come in the order. So if a of I is not equal to a of I minus 1, then those are unique elements. Okay, and I will increase the count by 1. Otherwise, if they are same, then they are duplicate elements, and I will increase the value of repetition by 1. Now I will have three components. We will take three components here. The cost of removing a duplicate element, it will be repetitions times c. So for what we are doing in the greedy approach is, for each and every iteration I am calculating the minimum value of answer which we can get. For example, is if 1 2 2 is there, and after that, here if I am taking 1 2 2 is there, 3 and 3 are also there. So when the loop is still 1 to 2 only na, then the repetition value will give me the value 2. For that much I will get a answer. After that, when I will iterate ahead, I will get more values, but the answer will be the minimum of all those. So in this case, we are we are considering this part. So cost of removing duplicate in each and every iteration, in each and every iteration. Okay, then the cost of adding the missing elements, how we are going to calculate this. So after I have sorted the array, I will see that if the count is 3, for example, here I have written in an example, if the count is 3, okay, and the value of a of I is 5, that means the fifth value is at a third position. That means two values are missing. So what I will get is 5 minus 3. Two values are missing. So a of I minus c and t will give me the number of missing elements, and the cost of adding them will be this part times d, two elements times d. Then after this, cost of removing other elements ahead of that. For example, I am considering 5 till here, and if after 5 there are two more numbers 7 and 8. Okay, so till that place I am not required to calculate it. So I will remove the values ahead of it. and which will be n minus I. Okay, I is the CNT. Okay, this is also I. Okay, so n minus I times C will be the value which I will get after removing the extra values which are ahead of it. After that, the answer will be minimum of all the answers which I will get in each and every iteration. So it will be minimum of answer, comma, cost of removing duplicate plus cost of adding missing element plus cost of removing other element. In this manner, I will get the value of answer and it will be the final solution. This is the greedy approach. Now I will discuss the DP approach of this.
So good evening.
Hello.
So good evening, guys. So this is the second problem for the today's episode.
Of this problem. So I will similarly there I will take the input NCD, declare repetition as 0, answer and position as 1. Now I will take a map of values and its bool value to check whether I am getting it as a duplicate or not. I have taken the inputs and defined a vector int a. Okay. Now here I will define the DP vector. So it is a vector in vector which will have two values declared as 0. It will look something like this. This is the initial state when it is not filled by any value. After that, I will take the inputs. I will go through the loop 1 to n. I will take the input. If the value is not present, uh, then I will go in this part, if part. And after that, this check will become true. I will push the element in the vector and increase the value of position by 1. After
ये
that,
खुद बना लो दीदी ये तो आपको बोला तो बनाने के लिए
if the element again is inserted there, then it will skip this part and the repetition value will increase by 1. Okay, this much part should be clear. After that, I will again look for the worst case which I have to discuss, which I also discussed in this part, which is this n times c plus d. Okay, here also it is the similar thing which I am doing here, which will be if one is not present, then again I will remove all the repeated values, only the repeated values, and add one. Okay, one is not there, then I will add other. Otherwise, if one is already there, then I will only remove the repeated values and decrease position by one, since I have already declared it as one. Okay. After that, I will sort the array. Then I will go through the DP vector. This is the main part of the solution. So I will go till the position, which is the number of unique elements still here. Okay. So how I am defining this is that dp of I comma 0 is the cost of removing a duplicate element and continuing from the previous state. What this means is that in this case I am considering when I am removing the duplicate elements which are already present there, and whatever is the minimum till the previous state I will take that part. Okay, and dp of I comma 1 is defined as the cost of adding missing numbers between the current and previous element. So what this we can say that I am in this part I am building the permutation, and in this part I am checking if there is already some part is present. Okay, already some part is present, then I will take the value from here, because in that case this will give the minimum value. Otherwise, building the value till here, okay, building the value till here will give me the minimum of them. So in each and every step here, I am taking the minimum of these two previous states. Okay, these are the previous states. For example, 2 comma 0, whenever I will go into dp 2 comma 0, I will look for the minimum from dp of 1 comma 0 and dp of 1 comma 1. So in this manner, I am using the previous states in each and every iteration, and this is the main part. uh, this is how the DP table will be executed. Okay, this part should be clear, I think. DP of I comma 0. Now I will explain DP of I comma 1. This is since I told you I am building the value till here. What I will do is again check if the elements are skipped. Okay, again I am seeing that if A of I is 5, okay, and the previous element is 3, element before 5 is 3, then one value skipped we will get this 5 minus 3 minus 1 times d. This will become the value of adding 4. This is just an example which I am giving just for the clarity. For example, when a of I is 5 and a of I is I minus 1 is 3. In this case, one value is missing, which is 4. We have to add 4 here, and whatever is the value behind this 3 will be taken from the previous state. In this manner, I will get the value of the next state and I will use it in this part. After the whole iteration is done, I will print the answer, which will be this answer, which is already defined here. For the case of repeated values, I have already told I am taking this as for the repeated values because we always have to remove the repeated values. We cannot skip that. After that, we will take the minimum of this, the end n minus 1, which is in this case is position minus 1 comma 0, position minus 1 of 1. The minimum of these will give me the answer of building the permutation till that part, and this is repeated value, and finally I will print the answer. So this is the explanation of the solution, DP version. I can execute this also. Wait, how do I? Okay. So this is the output: 0 to 8, 14, 23, 12, and last value, which is same as this part: 0 to 8, 14, 23, 12, 9 and 8. So this is the solution of this problem. Hope this helps. Thank you.
The name of the problem is maximize total cost of alternating subarrays. So first of all, let's read the problem statement first. Uh, it's given that we are given an integer array nums with length uh, and they define as a cost. The cost of the subarray nums L to R, where L and R is less than N, and L is less than equal to R. So the definition of the cost is as the cost of L to R means the cost of subarray from index ranging from L to R. It will be alternating plus minus. So it will be first it will be positive nums of L minus nums of L plus 1. It means alternating plus minus till the Rth value, Rth index. So we have to our task is to split nums into such subarrays such that total cost of the subarrays is maximized, ensuring that each element belonging to exactly one subarray. More formally, nums should be split into k subarrays where k is greater than 1 at indices I1, I2, and ik minus 1, where all of them should be increasing and less than n minus 1. Uh, so we have to maximize the total cost. They are asking for return an integer denoting the maximum total cost of the subarray after splitting the array optimally. So let's read the problem statement once again. So basically, they're asking us to maximize the cost here. And the definition of the cost, as I have read, it's the alternating sum of the subarray we have chosen. It will be nums of L and then alternatingly plus minus of the values in the subarray. So let's take the try run the some test cases. Uh, so first nums array is given as 1, -2, 3, and 4. So if we have to take subarray which take 0 to 3, then the cost of 0 to 3 will be nums of 0 with plus sign minus nums of 1 with negative sign, then nums of 2 with positive, and then nums of it will be 3 with positive. So what we have seen here, it will be 1 minus plus 2 plus 3, then minus 4, it will be 2. So it's one of the possible subarrays. Now we again break the subarrays from 0 to 1, then 2 to 2, and 3 to 3. So let's check what's the answer. It will be 1 and minus of minus 2. So it will be plus 3. Then cost of 2 to 2 will be 3 itself, and cost of 3 to 3 will be 4 itself. So our answer is 10. So we can see that this is the maximum answer for this uh, particular array nums. So once again, let's try run the another test case. We have nums equal to 1 minus 1 1 minus 1 this time. So how we should break the array into such subarray such that the some cost will be maximized. So we can break the subarray into two parts, which ranging from 0 to 1 and 2 to 3. Why this will because the negative part of this subarray will be turned positive, and it will add positive to our answer, that will be 2, and another subarray similar to this will also give 2, so our maximum answer will be 4. So basically this was the answer for this question. Now uh, how should we approach this problem? So let's look at the brute way. So while looking at this problem, we have to notice some patterns. How we have to uh, split the array into sub arrays. So as we notice that we have to split the sub array into some sub arrays, which means that we have to divide array in such a way that any element should not be left out. It means all the sub arrays should be continuous after that. So let's take an example. Suppose we have an array in nums equal to a1, a2, a3, a4. Then at most we can have three subarrays at maximum. That will be a1, a1 to a1, a2 to a2, a3, 3, a4 subarrays at maximum. That will be a1, a2, a3, and a4. Mm. So what we can think is that we are actually making different subarrays by putting we can actually assume that we are putting some barriers to create some subarrays, so such that if we will remove this, then there will be two barriers here, and when we will take this as our subarray one, this as our subarray, or we can either delete this or we can put this. So at a particular index, we can have at most two choices, that either we should put barrier here, it means we should end our subarray here, or we should continue our subarray furthermore. So it will be basically the number of barriers we can put, or it means the number of subarray we can generate. So at maximum we can put this hypothetical barriers is that it will be n minus 1, because if we have four elements, then we can have at most three barriers which we can put here. So it will be it for n equal to 4, it will be 3. So for n elements, we can have at most n barriers. It means we can generate total n subarrays from 0 to uh, length n minus 1. Uh, so so to generate one permutation of this, we will we have to take n of n time complexity to calculate our cost. So if there are if there are two raised power n minus 1 combination, we will require n into 2 raised power n minus 1 as our time complexity, because total number of permutation this can generate is 2 raised power n minus 1, because uh, for one of these barriers we can have either we will put the barrier here, it means we can end the subarray here, or we will continue. So all of them will give us as a number of combinations equal to 2 raised power n minus 1, and time complexity to calculate one such answer for single permutation is O of n. So this will take total of n into 2 raised power n minus 1, which will definitely not work, as our and is tending to 10 raised to power 5. So we have to think some optimal answer for this question. So let's read what will be the optimal approach. So so we take again some example array of nums as a1, a2, a3, a4, a5, and a6. So let's put the barriers randomly or generate. It means we generate our uh, subarrays. So if we don't put any barrier, it means we are considering the whole subarray, whole array as our subarray. So the cost that will be generated is a1 minus a2 plus a3 plus minus a4 alternatingly till a6. So this will be the cost. And if we put the barrier here, then again the cost will be same as above, because till here till the first four element we will have our cost will be a1 minus a2 plus a3 and minus a4, and for a5 and a6 the last two element it will be plus a5 and minus a6. And again, if we put this barrier here, hypothetical, if we, it means we are creating subarrays as a1, a2, a3, a4, and a5, a6. So our answer will be again as a1 minus a2, a3 minus a4, and a5 minus a6. So all of them are coming similar. It means we can notice such pattern and we can reduce the time complexity of our solution. We can see that there the result is repeating at different subarrays also. So so how to reduce this? So if we will again take the example and check what's the cost for this subarray. The cost will be again plus this one. We are taking only signs and not we are trying to observe some patterns here. So if we will take all whole array, then what will be the pattern? It will be plus minus plus minus. And then if we try to make it in two segments, such that segments one lie from 1 to 2 and another segment lie from 3 to 4. So again its answer will be plus a1 minus a2 plus a3 minus a4. So this is given as our answer, but it's similar to the above. It means we can the, we can take a number of segments in between and make our survey. But what is the minimum segment we can take? Because as there are many segments of length 2, 3, and many more lengths. So we have to generalize the thing. So we deep down look at some patterns. So if we take one length subarrays, then it will be always plus 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 and plus. So we can also generate our answer from taking one as our subarray. But this one will not always. This one will always only work when the all elements are positive. But suppose if this is minus some bigger value, then this will reduce our answer. So this one will be the not the this one will not be the optimal answer. So we have seen this. If we have even length subarray, then we can directly take uh, at a distance of 2. Suppose we have length 4 array, then we can divide it into two length subarray, uh, and then take the sum, then take the cost. It will be plus minus plus minus. It will be same as taking whole subarray at a in single. So so we have de defined the if the array is an even length array, then we can take two length subarray continuously till the end of the subarray. This will also generate the same. But what if there is a odd length subarray? This means that one will be left. One element will be left, and we by default have to take by default we take plus sign with this answer. So so as we can see this, for an even size array, we can calculate our answer just by using considering two elements at a time. It means consecutive consecutively two elements at a time we can consider. And for odd size subarray, the single subarray will be left, which can be considered with plus value. It means now we have reduced our problem to two operations which are taking consecutively two elements at a time. This means this operation, or taking one element at a time, or this operation. So these are the two major building block for our answer, and we can take these two operations in consideration. So we have got two operation in which either we can take two elements at a consecutive element at a time, that is plus minus, and either we can take one element at a time. So this boils down to our approach to DP approach, where we can reduce our time complexity from exponential to linear with the help of DP. So how DP can be helpful here? So we have noticed one thing, that in any way we can either of these two operations. So we have to do something with this operation, and we have to calculate the max of both of them. So if we will notice in this problem, uh, this is index, this is nums, and this is DP value. So till index 1 we can only take 1 as our answer, because this is the maximum till index 1. Now till index 2 it will be the maximum of either the first operation, it means considering two elements at a time, or the single one. So let's check. If we will take if we are here, then we will take two elements at a time. This means we will take 1 minus minus 2. This means we are doing plus 3. But if we will take 2 1 1 7, then we will get 1 and minus 2. This will give me minus 1. So taking two one length subarray does not make a bigger value than taking two consecutively elements at the same time. So for this index, the maximum value will be given by the two consecutive length operation. This means plus with 1 and minus of minus 2 with 2. So this will give me 3. And now for this, either we can do consecutively of these two, or we can do plus till here and take the DP value. So here we can check is what's the, so let's define the what is the base case for DP. So we are making a here one base indexing, because before this element DP holds nothing. It means there will be nothing in the DP. This means the DP of 0 will be 0. It means we are considering nothing. So it will be represented by index 0. It means out of bound, and the answer till here will be 0. So now what will be our transition state? So we can consider two type of operation. So first one was considering two at a time, and this will occur only after and equal to the index 2. This means we after this index only we can take operation of type 1. This means considering two at a time, because otherwise it will go out of bound if we'll consider it from index 1. So this will be uh, so if we consider this operation here, this means we are taking one. If this is index, then we are index minus 1 with our plus. So index minus 1 is our at plus, and index is with negative sign. And the DP value that holds before these two elements, it means the maximum till index this element. So if I explain this, so this will be 1, this will be minus 2, and before this DP this is there is nothing. So if we will so the maximum answer here will be considering two at a time, 1 and minus 2. So this will be minus 1, and considering two at a time, this is 1 and minus 2. So the max of this will be 2. Why this is 3? And because considering these two elements at a time, this means we got +3. And what's the maximum value behind this index? So it will be index, -1, it will be index -2. So that's why is the maximum value we can hold till index -2, and the current sum we get by using operation. And another operation is that we can take the single length array, uh, just doing plus with that index. It means if we are at this index, then we can take with this plus sign and dp the maximum value which hold till here I-1. So it will be nums of I plus dp of I-1, and dp dp of I will be the maximum value of these two operations we can get. So what's the final answer? We have to just return dp of n, where dp of n will be the maximum value we can create through this either of these two operations till the nth index. And so we will return dp of n as our answer, which is the maximum God we can get over the all server. And the optimal approach boils down to time complexity O of n. It is just linear solution. So let me show you my accepted code. So this is creating a dp array of n+1, and dp of 1 will be nums of first value only, because we cannot take operation 1 because there are not two elements. So we will just loop from index 2 to index n. We can either we have declared to take 1 and take 2. So it will be operation 1 is this one. I have taken it as take 2. It will be previous of previous should be in plus sign, and current should be in minus sign, and previous should be in plus sign. And beyond that, dp of I-2 means maximum value till the previous two, skipping the previous two element. And this one is the operation taking one at a time, where with nums of that index should be in plus sign, and before that, what is the maximum value of dp that holds, and we have to take the maximum of these two, and we have to return the answer. So this was the explanation for this problem.
So this problem is from CodeShare, distinct values. So first, let's read the problem. The beauty value of an array is defined as the difference between the largest and the second largest element of an array. Note that largest and second largest can be same value. Okay. So the beauty value of an array defined as the largest and the second largest, a difference of the second largest and the largest value of the array. So 2531. So value will be 5 minus 3 equals to 2. So you are given an array. Your task is to find the total number of distinct beauty values among all the subarrays of length greater than 1. Of course, 2 and greater than equal to 2. So let's see. So first you have to take the test cases, and n goes to 10 to the power 5. Let's think something in brute force. What will be the brute force? How to calculate distinct beauty values for an array? A1, A2, A3, A4. So this is our array. So in brute force, what we can do, we will calculate for every subarray of length 1, 2, and length 3, and we will calculate its beauty value and keep it in our set. So this work in n squared time complexity, definitely it will not work. So how we will optimize it? Let's check for a particular value, particular index I, how it will contribute in largest or as a second largest element. We are assuming that rather than the ith index, other elements are in sorted fashion in the array. 1, 2, 3, 4, 5 are in sorted fashion. Starting from I, let's check in subarray of length 2. So for length 2, the second largest element will be 1 and the largest element will be 3. So their difference will be 2. So we will keep its difference in a set. Let's calculate for subarray of length 3. 3 and 2 will contribute difference 1. We'll put in our set. And for length 4, uh, 3 minus 3 will be 0. We'll put it in our set. Next for length 4, 3 minus 4, its modular will be 1, which is already present in the set. Now, when we will take the whole subarray, then we can see that our maximum element is 5 and the second maximum element is 4. So here 3 is not contributing as a maximum or as a second maximum element. So we can conclude that whenever we will get an element which is greater than the particular ith element, it then that will be the last position when this element could be a largest or second largest element. So let's take a test case 8172 8172. Starting from index 1, uh, I will take a stack which will keep the element in the shorted fashion. Initially, our stack will be empty. So whenever I will start iterating from the first index. Uh, let's say our stack is empty, then I will put the first element in our stack. So it will be in our stack, and this I will keep a set for distinct values. So next, I will go to 1. It will compare with the top of the stack. In stack we will have 8. We will calculate its difference, which will be 7, and put it in our set. Then I will insert 1 to our stack, and now it's turned of 7. Uh, we'll check the top element of the stack, which is 1. We will calculate its difference and put it in our set. So here, what we have concluded that our array should be in shorter fashion, or our stack should be in shorter fashion. So 1 is less than 7, so we will pop it out. So I will pop it out 1 from the stack. Now 7 will be compared with 8. Their difference will be 1. I will put it in the set. So after that there is no element in the stack, so I will insert 7 in the stack. Now it's turn of 2. It will first compare with 7. So 7 minus 2 will be 5. I will put it in this set. As a 7 is greater than 2, I will conclude the operation, and same I will do from backward side. So let's see the code. So I'm taking input and the array, and I'm keeping a set for distinct values. Let's see my function. So I maintain a stack. Initially, if the stack is empty, I will put the array element in the stack. And now, if the stack is not empty and the um, uh, top element is less than the ith element, I will pop it out and compare. I will calculate the beauty value and put it in our set. At the end, if the stack is not empty, I will again compare the top element. Just let's say what I was doing for 7, I was first comparing 1 and 7, and if 1 is less than 7, I will calculate a beauty value and I will pop this value because 1 is less than 7 for 8, but for 8 is greater than 7, so I will not pop it out, but just I will calculate its beauty value. So what I am doing here, and we have to do from front. So for an array, we have to do this operation from front and as well as from back. So I'm also creating an array, second array, which will be the reverse of the initial array. And for both the arrays, I am just running this function and putting all the beauty values in our set. And at the end, I'm just printing the size of the set.
Done.
Huh. The recording of figure.
Meter. So basically, you will be given two trees of size n and m, whatever, and then you need to connect a node between, basically connect an edge between both of these trees, and you need to minimize the diameter of both the tree, basically the entire tree. So, so basically, let's say you have given a tree something like this, and you will be given another tree, let's say this one, and then you need to basically add an edge between these two trees such that the diameter of the entire tree is minimal as mean as possible. So what is the diameter of a tree? It's the length of the longest path between any given node u and v. So for this tree, the diameter of this tree is nothing but this edge, this edge, this edge, and this edge, which is 4. And what is the diameter of this tree? This one, this one, and this one, that is 3. And what our goal is, we need to add an edge between these two trees. You can select this node and this node, this node and this node, any particular node to any particular node between these two tree, and you need to minimize the diameter of a tree, entire tree. So what is the first idea is, what you can do, right? Let's say you want to connect this node with this node. What will be the entire diameter? We know the diameter of this was 4, and we know the diameter of this is 3. And since this is 1, basically 1 edge, so if we count the entire diameter, it's 1, 2, 3, 4, 5, and 6. Let's say we take another edge and let's try to connect with something else. Let's say we select this node and this node. What is the diameter now? It's 1, 2, 3, 4, 5, 6, 7, 8. It's even worse now. Let's say we select another edge, basically another node. Let's say we select this node. Now what is the diameter? If you follow this path, basically this path, then the diameter will be 1, 2, 3, 4, and 5. Okay, it is better than the previous one, which is 6. And but this is not the diameter of the entire whole tree. The entire whole tree, the diameter of entire whole tree will be this node and this node. This is 1, 2, 3, 4, 5, 6, 7, which is 7, which is even worse. So what did we see? No matter where you connect the edge, our answer is going to be, well, like, what is the best place, what is the best node to attach a edge between two nodes, basically two trees. Like, why should I attach an edge to this node? Why? I don't like to attach this node. I mean, we should not attach this node to here. The best place should be the middle portion. Like, let's say we have some tree and something like this, and we will attach an edge to such a node which lie in the middle of our tree, something like here. Why do I do that? The reason is because, let's say 2 nodes are here, not counting this and this, and 3 nodes are here. If you select this node, then it will be even worse for this entire tree. What I mean to say is the path for this diameter of a tree will be assume this one, like this one, which is 4, 1, 2, and 3 and 4. Why will I connect an edge starting to this node? Because then the diameter of this tree will be 4. But if I do something like this, like connecting an edge to this middle node, now what is the diameter? Connecting this node, we will connect in future to some other nodes. But let's say some tree is connected to this node, and if I try to count the number of edges, or basically the diameter of this tree, this will be the minimalist possible. Why do I say that? Once you get to this node, at max you can travel is 2 nodes. But in this case, in the previous case, if I attach an edge to this node, the maximum node that I can travel is 1, 2, 3, 4 nodes, which is worse. So the best strategy to connect the edge is we should find the nodes which is in the middle of the diameter of a tree. And there is a beautiful formula for this. Like we do not need to find which node was the middle node for the diameter of a tree. The key idea here is to observe is no matter uh, what is the diameter of a tree or which node to select, if the diameter of a tree has a even length, let's say something like this, then the best way, this is not the even length, something like this. Okay, this tree, assume this tree. The best way will be to put this node, put an edge to here, right? And no matter to which node you do it, the minimalist possible will be the diameter of a tree divided by 2. For any given tree, let's say this one T1, the minimalist edge that we can cover is T divided by 2, assuming D is the diameter of tree T1, let's say T1. Why do I say that? Assume this is the even length diameter of a tree, and if you select an edge here, this will be the worst one, because then it will travel 1, 2, 3, 4. It will have 4 edges. If you select this one, this side we are having 1 and this side having 3. So again, this is worse. But if you select nodes starting from this node, then it will be 2 to this side as well as 2 to this side. So minimalist is D1 divided by 2. This is for sure, no matter what. So our first ultimate goal should be to find the diameter of both the trees. Now, I just considered the even length diameter. What about the odd length diameter? Like something like, let's say we have 5 length of a diameter. 1, 2, 1, 2, 3, 4, and let's say 5. Now, what I am saying is, no matter which node you select, the diameter, the minimalist is that this entire tree can have is T1 divided by 2. This one is for sure. And since this has an odd length of a diameter, we need to add extra one. Let's see why. Let's assume you add an edge starting from here, then it will be 1, 2, 3, 4, 5. This is bad. If you select this edge, then it will be 1, 2, 3, 4, 5. Like not 5, 1, 2, 3, 4. If you select an edge starting from this node, but let's say I do from here, then it will be 2 on this side and 3 on this side. So 3 is best over here. So 3. If I select the edge starting from this node, it will be 1, 2, 3, and 2. So still 3. If I start from this node, it will be 1, 2, 3, 4. This is 4. And if I start an edge from here, this will be 5. So we see is the minimalist that we were able to do is 3, which is nothing but the entire diameter of a tree, which is, let's say, D1 for now, for T1, D1 divided by 2. And since this was the diameter of this tree T1 was odd, we need to add extra 1. And if we apply this same formula on this tree, the diameter of this tree is 5. If you divide it by 2, it's nothing but a 2. And since the length of basically the diameter of this tree T1 was odd, we need to add extra 1, resulting into 2 plus 1 equals to 3. And this is the minimalist that we were able to achieve. This was the whole idea to solve this problem. And the same thing we will do for another tree. We just find the diameter for T2 and then divide it by 2 and check if the diameter of that tree was odd. If so, we will add plus 1 to our answer. And don't forget, let's say we have a tree T1 and we have a tree T2 and we are going to add some edge, right? So the formula over here will be D1, the diameter of tree T1 divided by 2, and plus if it is if it has a odd length diameter, uh, let's say D1 mod 2 plus D2 divided by 2 plus D2 mod 2. Basically, this is what this is doing is basically if it has odd length of diameter, then it will add plus 1 to our answer. And
क्या हुआ? What happened?
I think net issue है उसके वहाँ पर.